Hello, everybody. My name is Tiffany Hall, and welcome to our July Code Jam, where we have data science students and software engineering students collaborating and working on the same team. It is a full stack event, as you will see. And so I want to say thank you so much for joining. We have lots of students with us tonight and lots of viewers watching at home. As I said before, my name is Tiffany Hall. I am an alumni of TripleTen software engineering program. I'm a full stack engineer, and I'm currently a product owner at Scholastic Inc., the world's largest publisher of children's books and a powerhouse in the digital education space too. Tonight, I am so excited. I've been waiting all week for this code jam, so I just want to jump right in. Let's talk about what is special about this code jam versus some of the other ones. All of them are so much fun, but tonight, not just joining students from the same kind of background and experience and program, but tonight we have both the students from the data science program with TripleTen and the software engineering program with TripleTen. And they are going to work together or have been working together for the last week to show us some amazing things tonight. You might be wondering what a code jam is if you're new, and if you're new, welcome. A code jam is a friendly competition at TripleTen, no cutthroat island here, but all the same, lots of competitive nature. They are super short competitions, only 6 days or less, where the team gets together and they jam out a bunch of code or data or really whatever we are tasking them with to meet our prompt. There are prizes, but most likely all of our students, much like when I was in the boot camp myself, are all competing for that one thing that we all want, which is more caffeine. We all need more caffeine here. Kidding, it's pride. We're just all fighting for pride here. Okay, our code jam from this last week has had 3 parts. 3, the data part, the coding part, and tonight is the presentation part. Last week, the teams were divided into teams of 5 students, 2 from the data science and 3 from the software engineering. And today we're going to see what they were able to produce. We challenged these teams to create an optimal route for summer vacations. Again, they only had 6 days, so we're going to see miracles in front of us tonight. Tonight, the teams are going to show off their projects, and then next week, the judges will be evaluating all of the data, all of the code, and the presentations. All of our results will be posted on the hub for our current students, as well as our socials if you're not a student of ours just yet. But if you're not a student of ours just yet, you can still vote for your favorite team tonight. If you're watching this on YouTube, you can go ahead and vote either in the live chat if you're catching us live, or if you're watching this on repeat, you can throw it in the comment section later. All you have to do is write the name of the team down, and then they will get a special prize from my cat Sharkfate. Hint, it's cheese. He loves cheese. All right, let's get to the presentations. I am very excited. We have so many teams tonight, which makes me giddy. Six teams. That's like 1 team for every day. Okay, we're going to go. All right, the first team tonight is the Code Crushers. The Code Crushers consists of Paul London from Data Science, Preeti Sagar from Data Science, Lily Anderson from Software Engineering, and Matthew Richards from Software Engineering. Take it away, Code Crushers.
So, hello everyone. I am Preeti, and on behalf of Code Crushers team, I'm very excited to present my project that is Park Hopper Routes. It is a route trip planning project for the nature lovers for exploring US national parks. So, for this project, we divided mainly our work into 2 parts. First one for the data science team, and second one for the software engineering people. We did the data collection, data cleaning, and route modeling part. The software engineering team took the data from us and they converted it into a deployable web app. So this README file contains all the details about our project, like the live demo, notebook, overview, the technologies we have used, and the data sources. For starting this project, the very first thing which we needed was the data, and we took the data from the official website of National Park Service using their API. And the second data we needed for the states and their coordinates for the user's home location. We took that from Kaggle's website. After getting the raw data, we did some analysis, explored the data, and we did cleaned up data, which included handling missing values, um, dropping the irrelevant columns which were not required so that our data is clean and focused. After doing the exploration part, we did pre-processing and visualization, which show using Folium. We used Folium for creating this map, and which showed that there were few parks in the data set which were not accessible by road. So we dropped these parks from Hawaii and less accessible area. And for the final part, we chose the accessible US national parks. For routing algorithm implementation, we took 9 subset of parks from these almost 400 parks. And on the basis of those 9 parks, we created the route modeling. So route modeling thing will be explained by my friend who is from data science team, Paul. He will take from here. Thank you.
Okay, hi everyone. My name is Paul London. I'm the other data science member of Code Crushers, and I'll pick up basically where Preeti left off with section 4, which is basically we're taking that small data set of 9 parks she just mentioned, and our aim is to create a route algorithm. As you all know from our other sprints, a good thing to do when you're doing any modeling is to make a dummy version of that. And in this case, we chose to just do a random chance baseline model, which literally randomly goes through the 9 parks and generates a randomly created route. And after we saw that, we decided actually to do something very ambitious, which is to incorporate actual Google Maps travel data, because it didn't make that much sense to just go linearly between 2 parks because it's a road trip and you're not going to be flying. So we actually set up a Google Maps API and got our own API key. And essentially, we ran all combinations of the parks through the Google Maps API and got all of the travel distances and durations. And for the other data science people, that was stored in an array and later used for the algorithms. Essentially, it's not really training, but it was used to basically program the algorithm to then find the most efficient route through those 9 points. Some of the stuff under the hood is here. A quick point though, the reason we didn't do slides, and I saw a lot of the previous presentations did slides like PowerPoints, is I wanted to emphasize most of our previous sprints were entirely contained in a notebook like a report, but this was a very special kind of collaboration and new to most of us, where we had to actually be generating files for the software development team, not necessarily in real time, but we had to at least be cognizant of it as we were going through. So just real quick as an aside, you can see we made some JSON files here for them to reference for the itinerary and stuff like that. We actually pre-rendered some of the Folium maps, and those were stored here, and a ton of Python scripts that were stored here. So a lot of the notebook code was copied and adapted for software engineering purposes, which is not something any of us were used to. Okay, we then defined the starting point, which Preeti mentioned. We used the coordinates of their home state. And we decided to implement the greedy nearest neighbors algorithm for this project, partially because of its simplicity, but also in this particular case, it should usually be mostly effective. Essentially, what this algorithm does is just marks each point visited as having been visited and then goes to the next nearest location until all points are exhausted. So the logic for that is here. And again, we're using that Google Maps data in real time to determine the distances that are optimal. We have a function for that, which then moved over with other functions into, for example, maps.py, which is what generated the maps for the software development team. And then there isn't really traditional metrics for this type of algorithm because it's not machine learning. So essentially, we just did a comparison plot of the two routes in Folium. You can see the red one would not be fun to do a road trip on. It would take you very out of the way, whereas the blue one was the optimized one. So it's a very clear visualization. We did some tables of the data here just for a bit of an easier view, but I'll show you the graphs because those are easier to go through. Some other visualizations. First, we visualize it like this, which it's not the easiest to read, but you can definitely see it's like a compare and contrast bar plot for either distance or duration. So I'll just briefly go through these. But the better visualization is actually a cumulative line graph like this. You can see that the random route essentially wastes a lot of your time by consistently staying longer distances and also longer travel times throughout the entire 9 legs of this particular journey. And then we just have a final report here, but that will be for the judges to look at. I'm not going to go through that right now, but the main takeaway for this is for future improvements, it would be good to do more look at different algorithms, maybe a more advanced one, that sort of thing. But that's pretty much the main takeaway. But this one generally works well enough. So I'll pass it along to Lily to actually go through the functionality of the site.
Hi everyone, my name is Lily and I'm one of the software engineers for the Code Crushers team. And I am just going to be going over our website and explaining how everything works. So as you can see, the beginning of the website, we do have a navigation toolbar over here that makes it easier for the user to be able to go to the section that they want to go to. The second part of our website is the actual map itself. Now, we decided to use our home states as the starting location, and the trip is ending in California, and also you can start from California going all the way to the East Coast. So I'll just show you. You can select a state. We'll do Florida. And that will pretty much show you the route and all the parks that you are going to go to. So starting at Florida, you would start at the Everglades. And if you click on the icon, it'll show you more information about the park itself that the user can then read up about. The route will then take you all the way and then end up in California. And if you choose another state, I'll go with California. It'll show you a different route starting from California. And then you can also come to the itinerary, which will show you exactly which parks you're going to be passing along the way. The third section is some featured parks that we have. So we selected 6 out of the 9 parks that we have. And these has all the locations, all the highlights, well, the top 3 highlights. We've also included the best months to go visit the parks. We also have a description so that the user can read up more about the different parks. The third section is some essential travel tips. So for anyone that's new that doesn't know what to plan, what to pack, or anything like that, this is a section that can be very helpful to them. We have all the planning information, what to pack, as well as some safety tips. And then right at the footer, we have everybody who was involved in the project, which is Paul and Preeti, who are the data scientists, and myself and Matthew, who are the software engineers. The challenges that we face with this project is that we pretty much started out as a team of 4, as one of our team members dropped out due to an illness. So that was very challenging to be able to do all of the work. When we deployed the website, we faced some bugs. Our images were not loading, so we had to do some changes with that. And things that we would like to improve on is that we would like the website to be able to have all, 48 states, because we're excluding Alaska and Hawaii, and have a lot more parks. And also for people that don't want to do a long road trip, starting from the West Coast to the East Coast or vice versa, they can do a shorter route and have access to more parks than just 9. Thank you.
Yeah, that was great. Thank you guys so much. There's some questions in the YouTube chat that I think you guys covered pretty well around how long does it take to get to, like Tommy was asking in the chat, like how long does it take to get to California? And so Lily, I think you hit on that with the like being able to do short trips versus long trips that don't have to be multi-stop trips with the way that you guys set up your app. So really great flexibility in thinking that through. All right, let's talk a little more about the actual project itself. So, a team of 4, very challenging, trying to get all of that done. But let's talk about the parts that maybe new for both sides, right? For data science and for software engineering is the talking to each other. How did that go? Trying to get the data over the fence, so to speak, to the software side and make sure software knew what data needed. How did that go?
That was definitely also challenging because I really had no idea. Like all I've done personally was like basic HTML websites like decades ago, like hobby ones. So the communication was actually pretty good though. Like they were like, we needed a JSON for this. This has to be a separate Python script, because I didn't mention it before because I was going a little long, but we were actually supposed to render the map in real time, but that would have been way more complicated. So I ended up like pre-rendering the maps for those 6 states. But I actually have the Python script like in there to do that. But setting it up was like proving challenging. So stuff like that, I think we communicated pretty well as far as like what we needed from each other.
All right. So that takes care of the data science representation software. How did that go for you guys?
Yeah, it was very confusing in the beginning because all I was hearing was data, 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 and I was like, what do I do with this? But it was a really good learning experience, and the communication was very good. Because Matthew and myself, we would ask the data science team like, what is this and all that stuff, and they would explain everything so then we would know how to use it. Also, I was also more comfortable working with React. So Matthew was okay that we were just going to use React, which was good. But overall communication was pretty good. We spoke a lot. We sent messages a lot. So it was a good team.
I'm so glad to hear that. All right. And then one question that I think is a great one to ask. You guys only had 6 days, but if you had one more extra day, what would be the thing you'd want to either add or tweak?
From the software engineering part, definitely would want to make it more responsive. Um, and also just add a little bit more animations. We just have that one car that's driving past when you're selecting the state, but I really wanted to add a little bit more animations to it.
All right. That's a good one. I like that. And data? You're on mute.
I was gonna let Tweety do this one, but it's okay. I
You
think
you
for
can
us,
always you can join.
uh,
Feel free to jump in and be
we can
like,
do we
I
can do
think it
half and half.
all.
We can do half and half. It's fine. I think by taking a look at the algorithm to make sure it, because if you have more parts, like Lily suggested, it's the problem with this algorithm is it's pretty basic, obviously. So it can end up like getting trapped in like a small region and like not escaping until like later on, and then it's like not an optimal route. So I would probably check that as we add more parts and more states, like Lily mentioned.
If one more day would have been there, I would have tried to make it more interactive, like we used for a few states, if we wanted to make it for all the states. So that was one of the things I wanted to do.
All right, expand the states. I like that. All right, well, that was our first team of the evening. Thank you guys so very much. That is the Code Crushers. So if you like them, you can go ahead and vote for them either in the hub, or if you're not a student of ours just yet, you can vote for them in our YouTube chat. That team consists of Paul London on data science, Preet Sagar on data science, and then Lily Anderson in software, and Matthew Richards also in software engineering. Thanks, y'all. Okay, let's go to our second team. Our second team tonight is the Butterfly Brigade, which sounds lovely. I would like to be in a Butterfly Brigade. Okay, Sabrina McField is from data, and then Victor Foreman also from data, and then we've got two people from software engineering. That's Ryan Melagrino and Liam Devine.
First, we want to say thank you, TripleTen, for giving us this opportunity to collaborate as data scientists and software engineers. I think we learned a lot about ourselves and about our work. So thank you for that. So our team is affectionately called the Butterfly Brigade, which refers to a group united by light-hearted, transformative, or beautifying purposes. So that is what the Sun Chaser Role Optimizer is. Here's our team. My name is Sabrina McField by way of Atlanta, Georgia. We have Victor Foreman by way of New Jersey.
Hello, hello.
We have Liam Devine by way of Tennessee.
Hello.
And we have Ryan Malagrino by way of Oregon.
Hello, everyone.
All right, you guys, our software is called the Sun Chaser. It is a road trip optimizer. So we all know how rigorous it is to travel. So we wanted to create a planner that helps travelers create the most efficient and enjoyable road trip to the most popular landmarks or attractions in the US. Now, most travelers, I'm sure anyone here can relate to, is most travelers are facing inefficient routes, which means their travel time is increasing. Nobody loves that, especially when you've been on the road for 10 hours. The costs are increasing, so you're paying for more gas, you're paying for more snacks or whatever you're paying for. And then the difficulty of prioritizing what you want to see first, especially if you're traveling with multiple people. And then the uncertainty of how much time you're actually going to need when you're there. So we wanted to create a solution that minimized the total travel distance, which minimizes the cost. We wanted to create an opportunity for them to prioritize high interest destinations based on the real world data that we actually created ourselves. And we wanted them to have the ability to customize their experience by filtering landmarks by type, popularity, or time constraints. So I would like to call my colleague, Victor, to the front so he can explain a little bit more about what this looks like on the back end before we show you what it actually looks like for the user. Victor?
Thank you, Sabrina. So on the data science end, behind the scenes, what's happening is we first started off with a distance formula. It will take latitude and longitude coordinates in somewhere on the Earth, and it will find the distance to another location of latitude and longitude, how far it is based on doing all these math calculations that replicate what's known as a Haber-Sign function. Now, the next function after that is actually what we have known as compute total distance. So we took that function and put it inside this one because we wanted to know when we have multiple locations to figure out what is obviously the total distance. So it can take latitude and longitude from one location, find the distance to the next, and then on to the next and on to the next, add them all up to get our total distance overall. Now, to move forward, we also know that like knowing a latitude and longitude isn't something that everybody knows at hand all the time. So we implemented what's known as GeoPy, which is something that's built in that can be installed into Python that actually takes an address and can convert that to latitude and longitude. We wanted to include that to make it more user friendly. So lastly, with all three of those things that I mentioned, we have what's known as find the best route. And we had find the best route, which would take all the locations that you need and take your starting location, which we call home, and it would find the best route, the optimal route to go to all those locations and then back home. And it will actually spit out a map that you see present in front of you right now. We have the blue route is actually the most optimal route starting from your home, going to all those locations and back to the start. The red route is actually a very randomized one that just shows that, hey, it's not always the best one. You see there's more distances being traveled.
Awesome. Thank you, Victor. Now we're going to have our software engineers share their screen so that you can get a closer look as to what's happening under the hood of the actual website. Ryan?
Thank you, Sabrina. My name is Ryan. This is our Sun Chaser website application. At the top, you have the title, and then right below, you have the form that you type in where you want to start, and then all the destinations that you would like to go afterwards. This is where all the Python functionality is implemented into our website. And as you scroll down, you see all of the locations that our mission that we want to accomplish while touring the USA. And it also has little div lines that we're using CSS to make different lengths, displaying like a route, showing how long it took to get to each location. And if you keep scrolling all the way down, you get to the footer, which has our LinkedIn's in it and the title once more on the left. The whole website application is responsive design. It's good for all different types of screen sizes and also on the cell phone. So, and then Liam is also going to show you how we connected the Python and the React.
Hello. I would also like to point out that we have it so you can put your address in here and it automatically links all the best routes. And for the Python, the input that you put for the address gets put passed into this here, which is where the user gets turned their address into a value, which then gets passed to the optimized route. And the optimized route gets the route, sends it into a list, which we could then add more information. Like let's say you wanted to go to a particular genre of theme, and then you get a response back that is the longitude and latitude of the places you wanted to go to, so it can be easily put on the map. And if it has an error, it can show up an error message. The API is here in a different folder. And then the best route function is here with this as a representation of what it might look like on the front end.
Thank you, teammates, for your very efficient explanation on Sun Chaser. So I'm going to take it back over here. So these are some of the technologies that were used to develop Sun Chaser. Now, I want to call Ryan back up because he's representing the data scientist, and then we'll go to Liam. And we want to just touch on some of the challenges that we had to face and overcome developing Sun Chaser. So, Ryan, can you give us some insight onto that? I'm sorry, Victor.
Yes.
I'm sorry, Victor.
And no worries. So on the data science end, we were using Jupyter Notebook, which I was using Python behind that, and we had a bunch of other installs into Python that we're using like Plotly, GeoPy, and things of that nature. And lastly, one of the biggest challenges really was Git and GitHub. We learned a lot about passing our code back and forth to each other, which was very humbling because we had some corrupted data. We had to retype a lot of stuff, and also we had some issues with installing some of the functions into Python, which required us to make a lot of manual functions, which is perfectly fine. But those were the two biggest issues that we had on solely our end of the data science portion.
Yes, yes, we've lost notebooks and all kind of stuff. So, Liam, you want to explain a little bit about the late nights that you had texting us in Discord?
Oh yeah.
Problems you were facing?
The hardest part was trying to get the front end working with the back end. What I ended up doing was, making the back end into a server and then just sending queries that way. But the fact that it was the first time for the entire team working, together, because none of us have ever done a code jam before. So that was really difficult, and we had to communicate a lot and just communicate the type of code that we had to send back and forth between each other and what kind of information we needed, which was very difficult.
Yes, and we did lose a teammate as well, so we want to point that out. So, and with those challenging schedules, we made it work. Ryan, I'm gonna call you to the front now. Can you share with everybody a little bit about how our team worked together and our processes and our challenges there?
Yes, we had many challenges. We pushed through them all. We had different time zones, we had different schedules, and we tried to be flexible with them. Sometimes we couldn't make Zoom calls. We lost a team member, but we were very good at communicating on Discord, and we had a set time that we met on Zoom every night to discuss all the problems we were facing and how we would overcome them. We were very respectful. Our patience was tested many times, but we pushed through and we finished and we showed up. And I think that we did a great job.
What are you talking about, Ryan? Only Liam crashed out. Now this I'm just kidding. We love you, Liam. You're awesome. All right, so now we wanted to open up the floor for any questions, if there are any. No, if not, we can.
I've got questions for sure.
Oh, awesome.
So yeah, I think I really appreciate that you guys took the time to kind of share some of the difficulties around having the same version on your local setup. That is definitely something that can be really tricky when you're starting to integrate with other teams, right? So, like Sabrina, you may have Python, I don't know, Python 4, and then Victor's got Python 7, and you're like, does that work? But that's where it works on my machine. Was there any type of like advice you guys might have, since you did have such a rigorous like set time, that like that is a great tip, is having a set time, whether you can make it or not. Like, this is when the office hours are, but like any advice or for any of you guys, from any of you around the versioning and making sure that everyone's locals kind of jive together?
Yeah, I think me and Victor struggled with that probably the most because of our difference in capabilities. But I was really grateful that Victor is like a math whiz, and he was able to, hold on, he was able to create one of our like main functions by hand, or by brain, if you will. So that really helped that he had that skill set in mathematics to solve that problem.
And to answer your question about like any advice with the versions and stuff, I would say always have extra copies somewhere else in your folder in case it gets corrupted when passing through to GitHub and
It's a great
everything.
idea.
I had the struggle of having one of the notebooks be corrupted, or I tried merging it and it got messed up, so that set us back. But I had to retype a bunch of other code. But it's always just good to have a backup, so that way you can start from where you left off.
Yeah, that's for sure. And then let's see, on the software engineering side, like what was maybe something that was a real challenge just on the engineering side, having to take in that data?
Personally, it was just connecting it to the Python. It's something that we never learned in school. I tried to find answers online everywhere, and one was there was many ways to do it, as I saw. So I downloaded Python on my computer and copied and pasted all of their code into it. And then
A good idea.
Yeah, and then I was trying to connect the API to it. I had all these functions. It was ready to go, and then something happened and all my code was replaced and deleted when
Oh no.
with all these pushes and pullings with GitHub and everybody, pushing and pulling. And I would say yes, definitely save all your work before
Version control.
pushing and pulling anytime.
Mm.
No matter how many times you push and pull, always save all your work.
It's good.
Yeah, that was the biggest problem. GitHub was very
Learned the hard way.
challenging.
No, that's really good advice. I mean, sometimes the best advice is like making sure the basics are solid, things like that, right? Because there's nothing worse than working on something for, hours or even days, and then all of a sudden it's gone because you pulled before you should have pushed, and then you've lost it and you can't get it back.
Yep. Yep.
For sure. Well, you guys look like you persevered through a lot of those challenges. And you guys seem like, even though you were down a team member, also, you were able to really put out a lot of great code and a lot of great data too. So kudos to you guys for your perseverance. Oh my God, I love it so much. This is what AI should be for. I mean, just gonna say it. This is what AI is for. That is my favorite thing ever. Although, Ryan, you're missing your tattoo. You're gonna have to. Oh, you're on mute.
We had many versions of this. Sabrina did this. This was awesome, and there was many different pictures, and some of them had my tattoo, some of them didn't.
Oh man, I love it. Well, it looks great. I think it's hysterical. I'm just going to stare at that for a minute. Okay, so that is the Butterfly Brigade. Thank you guys so very much. And that team is Sabrina McField and Victor Foreman from Data, and then Ryan Pellegrino and Liam Devine from Software Engineering. All right, and our next team up tonight is the team Endpoint. And so team Endpoint, I have their pre-recorded one, and then we'll talk to them after. So team Endpoint is Eli Adams and Michael Turner from Data Science, and then Samuel Rundell and Manahil Samyi from Software Engineering. All right, let me share the things. Boop. All righty.
Hello, my name is Samuel Rundell, and I'm one of the software engineers of the Team Endpoint, creators of the California Vacation Optimizer, which is made using React and Vite. Our original idea, which I made into the Stigma, was to create a website where the user would select the places they would want to go, and it would make the best possible route for them to take based on this information. The website would ideally take place on a singular screen where the map would take up the majority of the space, while having a sidebar you could use to select the locations and a search bar to manually search for them. Once you selected the places you would want to go, you just had to hit the Make Route button and it would show you the fastest possible route you could take. As you can see, the main idea of the website stayed mostly the same, but as the project progressed, we had to make some changes. First, we decided to place it in California based on the data provided by our data scientists, which showed it was one of the more popular states to visit. The main functionality now works with you choosing what city you want to start from and where you want to go, while selecting the places you want to check out along the way. Now I will hand it over to my other software engineer who will show you more of what the website has to offer.
Hello, my name is Manahil. So to get started on using our app, I'll type in 2 potential cities that a user may be traveling to and from within the state of California. So if we go with San Francisco and Los Angeles, and we hit search, what Google Maps is going to do is that it's going to put pins on the cities that we selected. And the way it's going to do that is by using the longitudes and latitudes that we sent to it. This map was generated using the Google Maps API. Now, after these pins are created, the sidebar will show us the potential locations that we can visit between the 2 cities that we selected. And if I select a few of these places, and click Make Route, then we have a route created for us. The way that this works is that the same way that we sent longitude and latitudes to the map to put pins on the cities that we're traveling to and from, the same thing happens again, except this time we'll send the longitude and latitude coordinates in a particular order that the backend creates for us. Google Maps will pin and connect each location in the order that it received them, which will essentially give the most optimized route to visit all of these places. We also used a bit of responsive design, and as you can see, when the screen gets smaller, the inputs for the to and from cities will move on top of each other, and these like and dislike buttons will also move below the images. Now we'll hand it over to our data science teammates who can explain how they collected their data and created the backend of this project.
Hello, this is Team Endpoint. We're going to be covering over the back end and the data science portion of this project. This is for Code Jam July of 2025. My name is Eli Adams, and I will be turning over to Michael Turner for the first part of this presentation.
Awesome. Thanks, Eli. So yeah, to first establish the problem here, our first challenge was to essentially figure out where our project needed to take place. We were able to find a larger data set and then filter it down, just building this heat map here. We all came together as a team, and based on the results of our number of attractions that we're trying to discover along our route here, we determined that California was our best option, as it showed both a balance of a large number of attractions, while also a large geographical area for us to plan multiple routes along. So outside of New York, Florida, Texas, we thought California was the best choice here. So to create the data set, like I said, we used a larger data set from Kaggle and one from explorethedata.com. These all had larger data sets of different attractions around the country. So we needed to first make sure that we got rid of any duplicate data, we got rid of any missing data points, anything like that, just to ensure that the viability of each data set was steady before we merge them into one larger function and then filter that down to just California. After we performed that, we were able to come up with these visualizations here to get a better idea of our data spread based on the top cities by number of attractions, the top categories around the state of California, and then finally based on the regions, Southern, Central, and Northern California. Next, we added the position data because without the latitude and longitude, our app would not be able to function. So we use the nominatum function from that GeoPy library, as you can see on the screen here. And this was able to geolocate each coordinate, based on the city and state location that we gave to the function. So this built a big function in there that was a huge help for our team in adding that latitude and longitude data, so that we were able to pinpoint each location on the map, which you will see on the next slide. And you can see here on the left and right. On the left is our different points of attraction with a 2-mile radius around them, and on the right is with a 10-mile radius around them. We decided to go with the 10-mile radius because it would allow the app to find more locations along the optimized route, so that we can then give the app different options when deciding which one to choose.
So here we are going over the back end part of it, which we needed to set up API functions for the front end to be able to pull, to be able to actually make the app itself. The core functions were places, which finds any attractions along the route that we make. Optimize, which reorders the attractions to find the shortest travel distance. Locations, which actually gives the latitude and longitude so it could be placed onto the map itself. There's some more advanced features which give like stats, which gives performance metrics. There's route points, which gives the coordinates for mapping based on the city that it's in, things like that. Here is this function specifically for optimize route. This is the most important one for this project. It takes all of the attractions, the endpoint and the start point, and it pieces it together to find the route that has the shortest travel distance between attractions. So it uses the nearest neighbor algorithm to find the most efficient visit order. And this is for the front end to actually build what the whole purpose of this project is for. So in conclusion, what did the data science team accomplish? We provided data infrastructure, which is all the API endpoints and all the functions so that they could build their app with a lot more ease. There's app content, which is the data set, which we created with all the things that me and Michael worked on together. And then there's the data-driven decision support, which like how we chose California, how we chose all the different things that we're using for this project. And yeah, that was our portion of the project.
All right, that was lovely. I know that I am most interested in the like most roadside attractions. There are a couple of people in the YouTube chat who are really focused on California, and so I'm sure they're happy to see that as well. But let's talk to our team endpoint tonight. So we've got some of our teammates with us here. Thank you so much for joining. And I guess my first question is, in thinking through how, kind of that same question, how things seem to work out going back from that communication between data science and software engineering. It seems like you guys really had a good flow figured out, lots of API endpoints, lots of really clear data. But I'd love to hear a little more on your perspective.
It was the back and forth was really good. I also love learning software engineering, and they were interested in the data science. So it was cool to go back and forth and teach each other along the way.
Fantastic. Always nice to be able to share a little bit of that. What was maybe something that was really challenging, having so many team members? There's a lot of code jams where we have 2 and 3 members on the team, but you guys had to really negotiate times and dates and time zones between 5 people. So how did that go for you guys?
Well, there's only 4 of us, like most of the people in this
Oh, I'm
thing.
so sorry. You're
And
right. There is only 4. I thought there was 5. My mistake. So much easier now.
and each of us were in a different time zone. So that was also really hard. We only got like an hour or 2 a day together.
So you guys really had to make that hour count.
Yeah.
Yeah.
There were
All right.
5 participants initially, but one of them had to drop out. So
Well, that seems to happen, right? So from the software engineering side, it'd be a great question. Like, what was one of the more challenging pieces in trying to make sure the data was showing as expected or as maybe hoped? Was it the hitting the endpoints, those API calls, or was it like the front end rendering? What do you think?
it was definitely the API calls, hitting those endpoints. We actually ended up naming our team that because of like how much the endpoint we had to show
So
so
much
much.
misery going into finding that endpoint.
Yeah. But once you get it, right? It's amazing when you get it.
Yeah.
Now you guys had quite a few that you were doing. Would you say that you had too many? Just enough? Do you wish you'd have had more?
We had
Most definitely, oh, most
No,
definitely
God.
too many, but we would like to have more if we had more time.
Yeah.
There was going to be more features, like a filter feature, the filter by what type of place you want to see, like a hotel or a restaurant or that type of reaction. But I mean,
Because
Yeah, I
like
saw
you
one where you
saw,
had like a hoot owl thing.
we had like 1,000 attractions just in California.
Wow. Well, it sounds like a really smart idea that you guys narrowed it down to just that state because it sounds like it would have been untenable just having the whole country there. So
Yeah.
good thinking. Fantastic. All right. Well, that was Team Endpoint. Thank you so much for your presentation. I really appreciate that. And I really appreciated you showing all of the endpoints too, because I think that's one of the things we talk about. But if for those who are watching, maybe not quite familiar what an endpoint is or what it looks like, it's really great to be able to see it. So thank you. All right, that team is Team Endpoint with Eli Adams and Michael Turner from Data Science and Samuel Rundell and Manahil Sami from Software Engineering. Thank you so much. Okay, now we're going to go to our next team, which is the algorithmics. They also have pre-recorded, so I will share and then we will chat with them at the end of their presentation.
Hi, everyone. We're the Algorithmics, and this is TripleTen USA. It's an interactive road trip planner that simplifies trip planning with optimized routing and immersive visuals. We built this to eliminate the overwhelm of choosing stops, calculating distances, and manually mapping routes. Let's dive in. The objective of this project is to design an optimized travel route for summer sightseeing destinations within the United States. By leveraging real-world data such as user ratings and visitor reviews, the project aims to help travelers discover the most popular and picturesque locations in a smart, efficient manner. The model enables users to select the number of places to visit and a starting point, then generates the optimal sequence of stops to minimize total travel distance and time. Key features of this project include an interactive map displaying the complete travel route, filtering options to customize trips by state, popularity, and number of destinations, and a clear trip summary showing total distance, estimated driving time, and a number of stops for better trip planning. The project is divided into 3 main stages: data collection and preparation, route optimization, and data visualization. The initial stage involved importing essential libraries and loading a large dataset from Kaggle containing 3,124 tourist destination records across the USA. Since latitude and longitude data were missing, critical for route calculation, these geographic coordinates were obtained through the Google Maps API and appended to the dataset. Comprehensive cleaning and validation steps were performed, including converting all column names to snake case for consistency, removing columns and rows with missing values, dropping duplicate addresses to ensure unique locations, confirming all entries are from the USA, verifying latitude and longitude values fall within a valid geographic bounds, and ensuring that all US states are represented in the dataset. These preparations guaranteed a clean, accurate, and comprehensive dataset ready for route modeling and optimization. The second stage was to develop an efficient sightseeing road trip route covering a selected number of top-rated tourist spots, visiting each location once while minimizing total travel distance. The process began by creating a baseline model that randomly ordered the destinations. The total distance and estimated driving time of this random route were compared to establish a performance benchmark. To improve upon this, an optimization strategy was applied using the nearest neighbor algorithm, which iterates through the top N locations and selects the closest unvisited location to the current point. This efficiently constructs a route, minimizing overall travel distance. Key highlights include the selection of the top 9 tourist destinations in Florida based on a weighted score, a custom metric combining location ratings and review counts. This balances quality and popularity, ensuring trustworthy rankings. The baseline random route resulted in a travel distance of 248.73 kilometers and an estimated driving time of 3.11 hours. The optimized route reduced the distance to 136.17 kilometers and a driving time to 1.7 hours, nearly a 45% improvement. The nearest neighbor algorithm ran swiftly, producing results in just 0.02 seconds, demonstrating the feasibility of fast, effective route optimization. In the final stage, the project focused on visually optimized routes using interactive maps. By plotting points, users can intuitively grasp the improvements in travel efficiency and route compactness offered by the optimization. Finally, we visualized it all with an interactive map, so users can clearly see the improvements in route efficiency. Some key architectural decisions: we're using React context for clean separation between a theme, route, and map. We use Map Libre and Map Tiler for customizable mapping, Framer Motion for smooth modal animations, and we fetch location images using the Wikipedia API. Some places either have no relevant image or a totally unrelated one. In those cases, we fall back to the placeholder image using placehold.co API. This is the modal and form mode, where users select a state, number of stops, and starting point. It's managed by our route context, which handles all the form state cleanly. Once the form is filled, the user clicks Generate Route. That triggers data loading, filtering, ranking, routing, and image enrichment. In here you can see it live, where we select California, 9 stops, pick a starting location, and then generate. When the form is submitted, we enter preview mode. The modal updates with the stop's image, name, address, the stop count, and the total distance and estimated driving time. The driving time uses 60 miles per hour as a baseline. And on the map, markers pop up for each location. A line animates between them, and we fly to the first stop to start. As you can see, after clicking Generate Route, we zoom into the first stop and our modal shows an image, name, address, the stop count, and then the total distance and estimated driving time at the bottom. You can also see the current stop details update as we cycle between the locations using the buttons at the top of the modal. And then to reset, click Generate New Route. It resets everything to form mode. We built a custom theme toggle using CSS variables and a global theme context. When switched, everything updates, including the map style, and we redraw layers and markers. And here's the theme toggling in action. We also made the design responsive, fit for any screen size above 320 pixels. In here, we show a full reset and rerun of the program. To recap, TripleTen USA empowers users to quickly plan and experience road trips using optimized routing, visual map interactivity, and theme-aware UI. We've built a fully modular, scalable tool with clean code, strong UX, and thoughtful technical design. Thank you for watching.
All right. Thank you so much for that presentation. Let's chat with the students in the algorithmics. We've got some of them with us on, and so I first want to know about using Map Libre. Why the choice in Map Libre versus like the Google Maps API or MapQuest? I hear they're making a comeback.
So Map Libre is really it was really just based on customizability and the ease of use. There's a lot of built-in functions and methods that made it really easy. Like the flying between certain points was a built-in method. I didn't have to do any sort of animating myself. It was just really just easier, I guess. Yeah.
Yeah, I mean, if it comes with all of those things out of the box, why fix it if it's not broken, right?
Yeah.
Fantastic. And then there was a lot of talk about the data set not having the latitude and longitude coordinates. And so I was just curious, like, was that something that was surprising for you as a team? Was that something that you had hoped would be a part of the data? Or was that something that was like, oh dear, that's a real blocker. We need to pivot.
Janina, did you want to answer that one, or is she here?
Hi. Definitely, it is a really difficult task for us because we don't have any idea how to link the latitude and longitude. So just search something, discuss in the group, and we will find out the latitude and longitude using Google API key. Finally, definitely it is a teamwork.
For sure. And then how was it working back and forth between the data science and software engineering? You know, was it something that I know it's a new experience for everybody, but did you guys feel like you were at all surprised at like what the other students have been learning?
Definitely. At the point when I share my program, we are in quite surprised that from the DS side, we use Python, and from the other side, they have no idea about it. So at that point, we were discussing each step in a meeting, then confront them, and a lot of work.
Yeah, it's quite literally two different worlds that you guys, two different languages that you guys are working through. Yeah, it's a really great point. And then let's see, any other advice you would have for other teams as they kind of move forward? And so about every 6 months, we try to have another one of these data science and software engineering kind of collabs. But any advice for those future teams?
Definitely communication barrier.
Yep.
Oh, okay, communication being a barrier. We're watching out for that. Any solutions you guys found to that?
I mean, I feel like communication was fine. Janina she took charge on everything, made sure to explain everything about the data science side.
Well, that's good. I imagine there's a lot of trust that goes into that too. Like if Janina and William were like, this is what we need to show, you guys on the software engineering side are like, great, yep, sounds good. That's what we need to show. All right. Thank you guys so very much. That is the Algorithmics. And that team consists of Janina Babu, William Mazzeo, Donovan Jabbar, and JJ Plamutil. All right. Thank you guys so much. All right. We are moving to the data and code miners. All right. Data and code miners. You know, I hear the kids yearn for the mines. And apparently so do students. So the data and code miners, we have Gil Fadu and Victor Klufinski from data science, and then Steve Bullen and Valerie Tsan from software engineering.
Hi everyone, we are excited to present our project for the DS+SE Code Gem, Best Summer Sightseeing Road Trips in USA. Brought to you by Data and Code Miners, because who doesn't want to see more, drive less, and make the most of their summer? So before we dive deep into the project, let me introduce my team. So our team consists of two DS members. Myself, Jill Faldu, I'm a DS, TripleTen DS graduate, followed by Victor, he is a student. Then we have a SE members team, Valerie, she is a graduate, and followed by Steven, he is a student. So before we dive deep into what our project has, let me show you our project overview. So our goal was to create an optimized road trip planner showcasing US landmarks to help travelers minimize distance. We developed baseline and optimized routes using location data and design interactive visualizations. So the result was a web app for efficient and engaging trip planning. After showing you guys our project overview, let me talk about the next important thing, our big questions. So our big questions were, first, what data do we need to accurately represent each location and support efficient route optimization? Next, how can we design a route that minimizes total travel distance while visiting each landmark only once? We also were asked how to create clear interactive visualization that helps users compare routes easily. Finally, how do we build a smooth responsive web app? So the most important thing to answer those questions is the data set. Our data set was manually curated of 10 popular US landmarks selected for their popularity and geographic diversity. The dataset includes names, states, coordinates, and categories. As it is a small and a clean dataset, we didn't need to pre-process any rules. After our dataset was ready, we did modeling. We did two different modelings, basic model and optimized model. As you guys can see on the right side, we have a snippet of our code. This code calculates the total distance of a route by adding up the distance between each pair of points using their latitude and longitudes. It applies this to a randomly ordered route that is called baseline route and prints the total distance in kilometers. The random route is kind of serving as our baseline to compare and evaluate how much our optimized improved the trip. So once our baseline, like base of the model was ready, now we are heading to our optimized model. As you guys can again see on the right side, we have a snippet of code where we used our nearest neighbor algorithm to create an optimized travel route. It starts at one location, like the first location, and repeatedly visits the nearest unvisited location until all places are covered. Finally, it calculates the total travel distance and the time taken to compute the route. Once both models were ready, we created kind of a map to compare both routes. As you guys can see, the optimized route in red reduced travel distance by over 35%, saving nearly 4,700 kilometers compared to the random route. It took just 0.04 seconds to compute, showing the algorithm is fast enough for real-time use in travel or delivery planning. Now, my team member Victor will go over different graphs.
Hi everyone, I'm a data science student and I'm going to take over from here. So each bar shows how far travelers drive between stops, and we designed the route to keep the journey comfortable and evenly paced. And that way no leg feels too long, and it helps travelers enjoy the ride without getting too tired. The next slide. Here we can see what percent of the total trip each leg takes. A good spread means the route is well optimized. No single leg takes up too much of the journey, and this makes the trip feel more consistent and even balanced. Next slide. This chart shows the distance growing with each stop. The steady curve means the route is direct and efficient. There is no big jumps between stops, and that means less backtracking or detours, and it helps travelers make the most of their time on the road. The next slide. Here, using the average speed, we estimate the drive time between stops, and it actually helps travelers plan their day more easily. They can see how long each leg might be take before heading out. This makes it easier to schedule breaks or sightseeing. It also helps avoiding driving too much in one day. And here we can compare the baseline and optimized routes. And the optimized one is shorter and it saves more time. And it also reduces overall train effort. And travelers can visit all the same places with less stress. And this shows the value of using data to plan smart trips. So we built a working road trip app, and in the future we would like to add more stops, filters, and visuals. And we also plan to include user preferences like nature spots or city attractions, and more charts and insights to help travelers make better decisions. And our goal was to make trip planning easier and more user-friendly. Thank you.
Hi, everybody. I'm Valerie. I'm part of the software engineering team, and I'm going to pick up on the presentation. So I have two main goals for this. The first main goal is basically to take the raw data from our amazing DS teammates and transform it into a fully interactive, user-friendly web application that's the second goal for me. It focuses more on a responsive design, especially for optimizing the layout for mobile, tablet, because I feel like road trips, you don't really use a computer that much, so you use your phone or tablets smaller devices. So I focused the design on that. From then, we kick things off by setting up the front end using React, Vite, and then I immediately integrated the Mapbox to create the interactive map with the custom image markers, as you can see. And then when you also click on it, you can see the name. Yeah. And then I built a scrollable card layout that displays seamlessly on both desktop and mobile devices as well. As you can see, the landmark list has the name, the description, the image as well. Well, not the description, the image and like the popularity, the rating. Moving on for the filtering and the sorting data. Yeah, I use React Select for filtering the data using keywords like historic landmark, national park, national wonder, so on and so forth. The same goes with the sorting logic. If you drop down, you can sort it by popularity, rating, or in alphabetical order. One last thing, the card layouts, when you click on one of the lists, you can also actually see the card. Yeah. And then there you'll be able to see the beautiful images, a short description, the ratings, the type as well for the sorting and filtering logic. And then as for the rest of the front end, Stephen, one of the other SE student, handled the header, the nav bar, the pop-ups for the login and the sign up, which we both collaborated on making sure that the designs are like combined all together. And that wraps up for the software engineering side.
Thank you.
All right. It's always that moment where I'm like, is that it? Are we done? Is there going to be any
Yeah.
ponies? I never know. All
Thank you,
right,
Sophie.
let's chat. So really interesting in terms of how you guys partitioned out the data, especially from a user perspective, in looking at like the number of stops, filter and button and drop down. Can you guys talk to me about what was that maybe first meeting where you had the data science and the software engineer teams come together for the first time? What was that kind of like to plan out what you wanted to achieve in such a short time?
I'll go. So in the first meeting, we all were confused, but the main part was like from where we get the data set. So honestly, like myself, I was like chilled down that, oh, Kaggle will use, I have done that before. But then actually when me and Victor, we started like looking up the data sets, we found out that most of the data sets, they have only one category. Like they might have landmarks or attractions, but they might not have um like historic place. So we wanted different categories so then we can pick and choose and the audience can select based on what they are looking for. So we kept texting Daniel, like I was the one who kept in like asking him so many questions, and he told that you don't necessarily need to use Kaggle or anything. You can manually make your own data set and you don't need to make like really big, or we just recommend like less. So that's what we end up doing because we already had natural attraction places, but we wanted to use different categories too. So he just told that why don't you all come up with like some input and you can make a data set by yourself, and that's what we did. So yeah, during the first meeting we all were confused and we are trying to plan what would SE would do, what would we would do, and then if they need to wait for us like for data to start doing stuff, and then Val was like no, we can start on our side. So yeah, the first meeting was kind of confusing.
Right? So Val, you said you could start without the data pieces kind of already being in place. Could you explain to the people that are watching at home, maybe like why you don't necessarily need the data right away?
Because I have to buy some time basically for them to get the data set. Well, first of all, that's the first goal. The second of all, it's that I also have to scaffold the project. So, and then making sure on my end, on the SE side, that I have to manage the environment because I don't want the issues of Git merges, Git pull, and all that kind of stuff. So for me, while they get their data on their side, for me, I have to manage the SE side, scaffolding the project, making sure that the environment is all good. And thankfully, the result is really, really nice.
Yeah, I agree. It was really nice. I like that you guys also were thinking through that mobile first lens. Did that change any of the way that you worked with the data side of things to be able to display that in a mobile first kind of format?
Not necessarily. I think the challenging part for me was more on um, when I deployed it. Honestly, when I deployed it, I used Plotly for the bar graphs. However, the data when I deployed it was too big, and it was unnecessary, to be honest, for an MVP. So I just recreated that bar graph and used a React charts. That's one of the challenges that I faced. And then it turned out fine with the CSS style, because the styling of it, because it's much more easier to manage, and also the size of the project for an MVP. Yeah.
Fantastic. Well, you guys did a great job. So even though you started out super confused, Jill, you guys figured it out and were able
Yes,
to come out with a really great product.
Thank you so
for
much.
sure.
Thank
All
you.
right, there's lots of chatter in our YouTube channel. There's lots of people who, let's see, who have voted for the endpoint, team endpoint. Yes, really liked that one. And the algorithmics. Let's see, there's a vote in there also for data and code miners. And then our last team of the evening seems to have stacked the deck because there are Ryan Bomarito has a fan club, it would seem. And so let's see what him and his team have for us. His team is, let's see, the team is fully stacked. And that team is our last team of the evening. And that team consists of Sohini Tamar and Rawal Yusuf from our data science team. And you may know them because they were in lots of our data science jams, just like Jill and Victor. And then we have a fan favorite, apparently, got himself like an entourage and everything. Ryan Bomarito and Farida Nelson and Matthews Jordeo from software engineering. So, all right, last team of the night. Let's go.
Hi, everybody. My name is Farida Nelson, and I'm representing the fully stacked team. We are a big team of five. Ryan, and Matthews are software engineers, and Sohini and Rawa are data scientists. So we've created Color Rush, which is a personalized adventure planner that lets users build a custom Colorado trip based on extreme sports that the user loves. It's very unique because it dynamically generates the Google Maps route between the selected activity spots, filters them by sport and the difficulty level, and lets the user save, preview, and revisit their dream routes. So here's the homepage. The homepage of Color Rush welcomes users with bold visuals and clear call to action, inviting them to start building their dream Colorado adventure. So it features sleek layout, brief app overview, and has a couple of sections, and the interactive header with interactive icons here. That take you to the home or the profile. Okay, here's the how it works section, which tells you how the website actually works. You choose your tag, then we find the best matches according to the level of difficulty and the activity type, and then you get a personalized itinerary. Here's the activity highlights section where we have hard-coded the highlights, where you can see the sport and the little info with the level of difficulty at the bottom. Here we have the example route that you will receive at the end of generating your route, which is the interactive map and life map. And then at the bottom, we have the testimonials section and the footer with active links to about frequently asked questions and the contact us page. Okay, so once you hit start planning from the homepage, it will take you to another page where you can actually create your route. You choose your activity, then you can, for example, between these, and then you can choose the difficulty level of each sport. That will pre-populate your route preview. You can delete some of them if you don't like that and choose others. And after that, it will take you to another page when you click the Generate Your Route button. The Generate Your Route button takes you to the final page, the optimal route page that displays the user's selected activities on an embedded Google map with the dynamically generated route. So this is a live map, and it also lets you save your route, download the map. Here are the saved routes. You can also delete them if you want. To download the offline map, you will have to visit Google Maps to do that. And then there's also a reset button that takes you to the previous page to start over. And from here, I'm gonna hand it over to Ryan.
All right, thank you, Farida. I don't think Matthews is here, so I'm going to go ahead and talk about.
Yeah, I'm here right now.
Matthews is here, so I'm
Yeah.
actually gonna let Matthews talk about the footer here and the design.
Of course. Yeah. So my role within the team was really the front end design. So what what I started doing just to start off with was just create a Figma project. Try to put something down here. While the rest of the team was the data people were just working on collecting the data, and while Ryan and Fredo they were actually working on building the site. It's my first time using React, so I was the more early on software engineering compared to the team. But so I focus more on just making sure everything was responsive and making sure everything looked pretty. So as you can see here for the about page, it has the title, it has all our photos and all our abouts, and as well this entire page is fully responsive. So regardless of the size of the window, so if it's on mobile, as well as there's like some slight animations there for effects. Yeah, and as well as from the about page, if you go back to the FAQ page, so our questions and answers, kind of just breaks it down for more than just what we have on our main page there. We have some drop downs, with the questions and separate sections based here. For our original Figma design, there's a lot of things that on the website that wasn't included with our Figma. We use kind of the Figma as basically like as a reference. And once we had the initial design, I just mainly worked on making sure everything was responsive, making sure everything looked pretty both on desktops and mobile versions.
All right. One thing that I worked on was I worked on the back end, and so I created this profile section where you can go ahead and log in. You can register and you can also log in. So here I have my information in there. So I'm just going to log back in. And so if you look down here at the profile page, you will also have your saved routes. Right now, these are locally saved, but in the future, we will have them connected to the database. I just did not have enough time to get to it. You can go in here and you can edit your information. So if I just delete my last name and save it, it will update here, and also in the header. We used two repos. We had a backend repo and a front-end repo. I did most of the work in the backend repo as I am the only one that got through pretty much the whole course. I'm on the final project. But in the front-end repo, We all used our own branch. We all created our own like little main branch here, and then we would all push to that, and then I would do most of the pull requests for that. I do want to go back to this and show between the 3 software engineers, we had 49 pull requests and over 100 commits. So we put a lot of work into this project. It is fully deployed, so there is a full-on website. It is this colorrush.serverpit.here.com, and I used AWS virtual machine to deploy. I want to go and look into the code real quick. One of the biggest challenges that we had was working with data scientists for the first time. They basically gave us a JSON file and a Python file. Now, I've never connected a Python file to a React, so I will go ahead and mention that this one file right here is made with AI because I had no idea how to do this. But I'm going to pass it on now to the data scientists to talk about their portion.
As a data science team, Suhini and I defined destination logic and analytic criteria. This decision empowered the software engineers to build scalable tools fueled by validated decision-ready data layers. After scraping and cleaning data, we selected 8 sites based on activity scalability and geographic balance, like north and south. We have 3 north sites and 5 south, like what you see in the sun-pressed chart. And terrain and elevation, accessibility and route optimization. This became structured in both for engineering. Our data parameters included coordinates and elevation, activity type and difficulty, path requirements, gear, camping options. Our visuals and analytics, using Folium and Plotly, we built interactive maps and sun-pressed charts to spotlight regional patterns and elevation trends. One insight, the steep elevation gain from Grand Junction to Spain, vital for planning high altitude activities. From here, I will let Suhini to continue explain the dataset.
Thank you so much, Rava. So for routing algorithm, I use Haversine function to do the math for us to find the distance between 2 latitude of 2 different locations, so that we can use it to find a base route model, which will be used as a reference point for our optimized route. So for optimized route, I used nearest neighbor to calculate the nearest location and create a route in that manner, but it will exclude the visited location. So every time the nearest neighbor will pick, it will pick a new location so that we can create an optimized route with that. So next slide, please. So if we can see in the map right here, on the right-hand side, you see the optimized route, and the total kilometer it covered was 1287. And on the left side, you see the base route, it says 1527. So you can pretty much see that we shaved 200 kilometers. So our optimized routing model actually works. So if in the image you can see on the right-hand side, you can see Rocky Mountains and Boulder. That is a straight line, smaller straight line going to go to that distance. But on the left-hand side, when you see you're going to, from Rocky, you're going to Aspen, and then you're going to Boulder. So visually, you can see it is taking more time, and you're covering more distance, right? So so I think we can conclude that our optimized model routing algorithm work. Next slide, please. So that was our conclusion. For the recommendation, I would say in future, we would like to incorporate live weather and traffic updates so that people can, or tourists can plan their routing better, and they can consider the safety consideration. We would like to expand activities, different kind of activities over different seasons so that people can enjoy it more. The other thing would be mobile app integration. We know it does a little bit, but we would like to expand that because everyone is on mobile right now. Nobody books or looks on the laptop. So I would like to do that. The other thing, we can also look into the camping and lodging location nearby so that we can add that up. Everyone doesn't have that budget to go in a hotel. Maybe they will bring a RV or, camp out there in a tent, and it will be effective. And that's my presentation. Thank you so much.
All right. Thank you guys so very much. Really great presentation. There's a comment in the YouTube channel from Introvision that says full stacked does not vibe code. They code the good vibes. I love that so much. Really wonderful. I think there's a lot of points that you guys brought up, especially in showing the comparison between the two map routes. And so, just kind of that question around what was the collaboration like between going from between the data science and the software engineering, especially because there's so many of you that have done jams before on this team. The time constraints, the kind of pace of things. What was that like in that first meeting, trying to get the things back and forth?
This was most difficult project up until now. Whatever code jams I did, I don't think I invested so much time in. That's what I want to, because thinking about that optimal route made me crazy. I was like, I don't know how to figure this out. And the Kaggle data set, there was no data set. So I was like, oh, then I realized maybe we can create a JSON. Maybe we can create but those things I want to get it out. It was hardest. I think it was.
And the other thing that as data science, I never interacted with software engineers. So we didn't know what exactly they do, and they didn't know what exactly we do. So we started to talk, hey guys, we don't know about you. So they started to explain, we do 1, 2, 3. And they asked us back, what is your job? How does this work? And since there, when we started to talk about our definitions for our rules, we started to see how we will pick up our data and how they will choose. It's one of the things is that we always say for them, the point that we would choose, you need to understand that you are able to do it. We can get the data set even if it's hard, but we need to know that for sure you can finish it.
Yeah, I think those are really great points, especially about asking each other in that first meeting, so what do you guys do?
When I said Jupyter Notebook, and they're like, what? I was like, oh no. Do they not know what it is? And that was scary, when we do other jams, everyone knows everything. I was like, what? You don't know what that is? We don't know.
And when they said JavaScript, I'm like, what is?
I don't know how it works.
I don't need any coffee, thank you.
Yeah, the optimal. Yeah, go ahead, Ryan.
A lot of words going back and forth, and we're like, do you know this word? And we're like, no, I don't know this word, but do you know this word?
And initially we were so optimistic. We are like, we will cover the whole country. And I was like, oh no. And we were like, okay, we can do this and that. And I was looking at the data set, but we can't find a data set. So then we were like, no, okay, let's make it smaller. I was like, I don't think we can fly and find this. And, that was hard.
Yeah, it seems like that was a theme throughout a lot of the teams tonight is, the data that you guys were kind of looking for in Kaggle and hoping for wasn't there. And so a lot of teams had to create data from nothing, which...
I spent 1 day and a half just to scrape data, and then we didn't get no data. It was a big shock.
And there were some sleepless nights for Frida and me because we were trying to figure it out. Certain things. She was on software engineer side, and she's different time zone from all of us.
Yeah, I'm on vacation and I'm 12 hours difference. Yes. Okay, so I had
even
to wake
more
up
of a time zone.
4 a.m. up around 5 a.m. or 4 a.m.
Yep.
Now, Frida, this was your first jam, right?
Yes.
Oh, yeah.
Yes.
How so beyond the 12-hour time zone because you're on vacation, how was the jam overall?
It was absolutely incredible. It taught me so much. I had to gain skills that I actually did not yet have. I had to learn all about the API key and the Google Maps and how you can actually make it, work with your app. It's just, it was a lot of really, really cool discoveries. And I'm really grateful that I've been here and my team is the best. Okay. I mean, seriously, everybody was so responsive. Anytime I needed help, Brian would help. Sahini, Rawa, Matthews, whoever, and it's really, really cool. The first meeting was like we were talking different languages, seriously. And at the end now, how we got it all working, it's incredible. Yeah.
Oh, it's fantastic. And Matthew said this is your first time too, yeah?
Is he
Oh,
here?
no,
Did I
he's at
lose him?
work. He's
Oh no,
at work.
I lost him. Oh, bummer.
Yeah.
Okay, well, I knew he was here earlier. Well, I one of the things that I think you guys should do is because and this is really for all of the teams, is that if you have the time and space and wherewithal, all of you as teams tonight, you had really great kind of next steps or like, here's where we would go with this project. And you guys especially, I know in the YouTube channel, there seems to be some other people who like me are from Colorado and would love to see the weather piece added to your app because the weather here in Colorado changes very fast, especially in the mountains. And so, hopefully all of the teams tonight, you guys will consider continuing on because this is something that you can really build on and both sides can be adding to their portfolio for sure.
Yep.
Really nice professional way to add experience that other junior developers might not have. So just, a little pro tip there. All right. This has been a lot of fun. I am very excited to get a chance to judge all the software engineering side of things. I won't be judging the data science things because similar to like what Sohini was saying, like when she starts talking to me about notebooks, I'm thinking it's like, the movie with Ryan Gosling, right? No, not that one. So thankfully not judging that, just judging software engineering. Okay, so tonight we had 6 teams. Please make sure, the YouTube channel has lots and lots and lots of chatter going on, lots of team recommendations and votes for all the teams have gotten some votes tonight, so super wonderful. I want to say thank you all for sticking around. I know that this is longer than our normal jam, but it is so rad to be able to have the data science students and software engineering students collaborate because it's a real thing, right? We're all learning in our little microcosms, and to be able to have to explain it to other teams is a wonderful opportunity to show those real world skills and get those portfolio pieces and projects that are going to set our students apart from others. So thank you so much for coming on tonight. To all of the students, I know that there were so many of you who were a little nervous at the beginning, and so I hope you're feeling less nervous now, but because you guys all came out with some amazing, amazing things. And it seems like, there was only one team at the end who was still with 5 people. So even still, 5 out of 6 teams were at a deficit, and you guys still were cranking out some amazing projects. So please be really proud of yourself. All right, that is going to wrap it up for us. All of our results and winners are going to be announced on August 1st on our socials and the hub. And please take time if you're watching this on repeat to make sure you put your team names in the chat. Again, we had so many. I'll go through those team names again. Team 1 was the Code Crushers. Team 2 was Butterfly Brigade. Team 3 was Team Endpoint. Team 4, the Algorithmics. Team 5, Data and Code Miners, and Team 6, Fully Stacked. All right, I want to say a special thank you to all of the people on my team who help all of these code jams go off without a hitch. And that is Devin, Camilo, Daniel, Elena, Liana, Anastasia, Dennis, and of course, my cat Sharkbait, because he is always there. I can't get him to leave me alone. He never stops. Thank you again to all the participants for your courage. And my name is Tiffany Hall. If you need to find me, you can find me at Tiffany Codes on Instagram, and you could probably find my cat trying to figure out how to book a cat-friendly hotel room with all of these optimal routes now. Thank you so much for watching and have a great evening. Bye, y'all.